The directions say to solve each exponential equation. Let's start with problem 1. 2 to the x plus 2 is equal to 64. Now, what we want to do is we want to rewrite both sides so that they have the same base. Now, let's take a look at 64 and break it down. 64 is equal to 8 times 8. So notice how I'm using a factor tree. 8 can be broken down into 4 times 2. And then 4 can be broken down into 2 times 2. And notice that 2 is prime. And I'm going to circle all the 2's. And I see that I have 6 of them. So 2 to the x plus 2 is equal to 2 to the 6th. So if 2 to the x plus 2 is equal to 2 to the 6th, x plus 2 has no choice but to equal 6. Solve for x. So x plus 2 minus 2 is equal to 6 minus 2. So notice I'm just subtracting 2 on both sides. The 2's cancel, and we get x is equal to 4. Let's take a look at number 2. Suppose 8 to the x is equal to the square root of 2. Now, I'm going to rewrite both sides so that they have the same base. Now, 8 can be written as 2 to the 3rd. The square root of 2 is equal to 2 raised to the 1/2. So 2 to the 3rd to the x is equal to 2 raised to the 1/2. Okay? But when you have a power raised to a power, you multiply the exponents. So 2 to the 3x is equal to 2 raised to the 1/2. So I'm going to rewrite that right-hand side here. Now, if 2 to the 3x equals 2 to the 1/2, 3x has no choice but to equal 1/2, like so. Now, let's see if we can get rid of that fraction. And the way I'm going to get rid of that fraction is multiply both sides by 2. So I'm going to multiply the left side by 2, and I'm going to multiply the right side by 2. And if you don't mind, I'm going to write 2 over 1. Now, 2 times 3x is 6x. Half of 2 is 1, so 6x equals 1. And let's divide both sides by 6. And when we're all said and done, we get x equals 1/6. That's number 2. Let's take a look at number 3. 3 to the x is equal to the cube root of 9. So 3 to the x is equal to 9 raised to the 1/3 power. And again, I'm going to rewrite both sides so that they have the same base. 9 equals 3 squared. So 3 to the x is 3 squared raised to the 1/3 power. But 2 times 1/3 is 2/3. So 3 to the x is 3 to the 2/3. And so that says x equals 2/3. Because, again, if 3 to the x is equal to 3 to the 3rds, notice how both sides have the same base. X has no choice but to equal 2/3. And that's number 3. So let's take a look at number 4. Suppose 3 to the x minus 1 is equal to 5. Now, this is much harder to rewrite both sides to have the same base. But never fear, we have a backup plan. So what I'm going to do is I'm going to take the log base 3 of both sides. So in other words, I'm going to say log base 3 of 3 to the x minus 1 is equal to log base 3 of 5. That is legal. Okay. Notice how the base of the log and this base here, the base of the exponent inside the argument, right? So notice how these bases match. And because these bases match, what you get left is that exponent of x minus 1 on the left-hand side. On the right-hand side, we get log base 3 of 5. And so I'm going to add 1 to both sides to solve for x. And I'm all finished. X equals 1 plus log base 3 of 5. That's number 4. Let's take a look at number 5. Suppose 7 raised to the 5x is equal to 1. Now, I want to rewrite both sides so that they have the same base. The base on the left-hand side is 7. Well, let's take a note here. Note, 7 to the 0 is 1. So what I can say is 7 to the 5x is 7 raised to the 0. But if 7 to the 5x is equal to 7 to the 0, 5x has no choice but to equal 0. And so, therefore, x is 0. That's number 5. Let's take a look at number 6. Suppose 5 to the 2x minus 3 is equal to 25. Now, this is one where I can rewrite both sides so that they have the same base. So 5 to the 2x minus 3 is equal to 5 to the second. But if 5 to the 2x minus 3 equals 5 to the second, 2x minus 3 has no choice but to equal 2. And so 2x minus 3 plus 3 is equal to 2 plus 3, right? So 2x equals 5. And if I divide both sides by 2, I get x equals 5 halves. That's number 6. Let's take a look at number 7. Suppose 4/9 raised to the x is equal to 3 halves raised to the negative 6. Okay. Now, this one's really, really interesting because there's a couple things in play. We can rewrite both sides to have the same base for the record. So what I'm going to do first is write 4/9 to the x, and I'm going to, instead of having 3 halves, I'm going to have 2/3. But when you write a 2/3, in other words, when you write the reciprocal of 3 halves, I have to change the sign of the exponent from a negative 6 to a positive 6. And so there's a law of exponents that I used. And it says something like, if a over b to the negative n, right, and I want to rewrite that, I can write this as b over a raised to the nth power. That is legal. Now, 4/9 I claim is 2/3 raised to the second. And so 2/3 to the second, and this is raised to the x, is equal to 2/3 raised to the 6. So 2/3 raised to the 2x is 2/3 raised to the 6. But if you have 2/3 to the 2x equal 2/3 to the 6th, can we agree that says 2x has no choice but to equal 6? And if I solve for x, I get x equal 3. That's number 7. And let's take a look at one more for this video. We're going to take a look at problem 8. Okay. Now it says 4/9 to the x plus 2 square root of x minus 1. That's on the left-hand side. And on the right-hand side, we get 9/4 to the x plus square root of x minus 1. So this one's a little bit more involved, but not too bad. So I'm going to write this as 4/9 to the x plus 2 square root of x minus 1. So the base on the left-hand side is 4/9. And if I take the reciprocal of 9/4, I get 4/9. But when I do that, I have to change the sign of the exponent. And when I do, I get negative x minus square root of x plus 1. So you notice I just change all the terms, all the signs of the terms, right? Notice how x became negative x, square root of x became negative square root of x, and negative 1 became positive 1. Okay. Now, I can set x plus 2 square root of x minus 1 equal to negative x minus square root of x plus 1. Okay. Now, this is what I'm going to do. I'm going to add square root of x to both sides first. And so I get x plus 3 root x minus 1 equals negative x plus 1 because the radicals canceled. Okay, now I'm going to subtract x, add 1. Subtract x, add 1. Why did I do that? The reason why I did that is because I want to isolate the radical on one side, put everything else on the other side. So what happens when I do that? On the left-hand side, I get 3 times the square root of x. On the right-hand side, I get 2 minus 2x. And then from here, I'm going to square both sides. So 3 square root of x to the second is 2 minus 2x raised to the second. On the left-hand side, I get 9x. On the right-hand side, I get 2 minus 2x times 2 minus 2x. And I'm going to FOIL that out. So 9x equals 2 times 2, which is 4. And then I'm going to get minus 8x plus 4x squared, right? I hope that's okay. Now, from here, I'm going to subtract 9x on both sides. And when I put everything together, I get 4x squared minus 17x plus 4 equals 0. And if I look and I get 4 times 4, if I draw myself a little diamond, 4 times 4 is 16, and the middle term, the coefficient of the middle term is negative 17. And if I want two numbers whose product is 16, but add up to negative 17, I can most certainly do that. I would have negative 1 and negative 16. Why do I do that? That tells me that that quadratic equation is factorable over, I can break it down, in other words. It's factorable. So let's write this over here. We get 4x squared minus 17x plus 4 equals 0. So I'm going to do the traditional guess and check. So I'm going to put a 4x over here and an x over here. Okay? And I'm going to put minus 4 over here. And I'm going to put minus 1 over here. And if you notice, negative x minus 16x is equal to negative 17x. So that would be the correct way to break it down. And so that tells me 4x minus 1 equals 0, or x minus 4 equals 0. And so x is equal to 1/4, or x is equal to 4. Now, we need to go back and check this. So let's take a look at x equal 1/4. Now, recall, this is the equation we're solving. It's 4/9 to the x plus 2 root x minus 1 equals 9/4 to the x plus square root of x minus 1. Well, I'm going to replace x with 1/4. And I get 4/9 to the 1/4 plus 2 times the square root of 1/4 is a half. And then I'm going to subtract 1. Does that equal 9/4 raised to the 1/4 plus the square root of 1/4 is a half minus 1. So what do I get on the left-hand side? On the left-hand side, I get 4/9 raised to the, now, these terms cancel, so it's 1/4. And then on the other side, I get 9/4 raised to the negative 1/4. That is indeed true. That is equal. Now, I need to check x equal 4. So I get 4/9 to the 4 plus 2 times 2 minus 1. Square root of 4 is 2, by the way, right? Now, on the other side, I get 9/4 raised to the 4 plus 2 minus 1. Now, on the left-hand side, I get 4/9 to the 7th. And on the right-hand side, I get 9/4 to the 5th. Those don't look equal, right? So it looks like x equals 1/4 works for this original problem. But if we go back to x equal 4, even if you go back up here, 3 times 2 is 6, but 2 minus 8 is negative 6. And so that is absolutely not going to work. So x equal 4 is going to get thrown out. So this is not true. And so the answer to this last example is 1/4. And that'll do it for this video, where we solved exponential equations and we worked 8 examples.